So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme of transformations with a focus on enlargements with negative scale factors. Now we'll be going through how to perform an enlargement with a negative scale factor, as well as going through how to describe an enlargement with this negative scale factor. Now, when enlarging a shape by a negative scale factor, not only do you affect its size and dimensions, but you also affect its orientation. Now, a negative scale factor will reflect the shape both horizontally and vertically. So, for example, if we took this shape here, which we'll just call A, and I've got my right angle, and I'm going to sort of colour in this top angle, and I'll colour this angle here. And if I call this O, A, B, actually let's use the colours so that we're not getting too confusing. Let's change the triangle. Let's just call the triangle X. And this is A, that is B. Now if I flip this vertically, then what will happen is that triangle will look like this. So here's the right angle. This angle here is going to be red, and this top angle will still be blue. And again, just in terms of labeling, this will be A, this will be O, and this will be B. And then flipping this shape horizontally, and what that then becomes is that's going to look, do that again, it will look this here is my right angle, which is O, this is going to be B, and this is going to be A. And if we just colour code those angles, blue angle and this angle here, red angle, let's call that red rather than orange. So as you can see, what you want to try and do is when you end up with a negative scale factor, you always have an idea of what the shape is going to look like in terms of its orientation. Now the best way for you to do that is, particularly if you're working on a grid, is to draw your vertical line and your horizontal reflection lines and then draw your shapes from there. So for example, if I had a shape that looked like this and this is my image, then what I would do is I'd first flip this horizontally or vertically. It doesn't matter which order you do it in. So for example, let's do this horizontally, so it would look like that, and then that would then turn into that shape there. So my two final shapes would be this one here, this one here. And so you want to have an idea, and once you get an idea of what the orientation is, you can then perform the enlargement by the reflective scale factor. So again, if it's a positive scale, a scale factor that's bigger than 1, you're making the shape bigger. If it's between 0 and 1 in terms of the digit, you're going to be making the shape smaller. And then obviously a negative scale factor will change the orientation like we've described here. So let's have a look at performing an enlargement with a negative scale factor. Now here, as an example, we're asked to enlarge the shape T by a scale factor of -2 using 2, 2 as a centre of enlargement. Now, just in case it's a bit difficult to see on your screen, this here is my centre of enlargement. Now there are two methods to do this, and again you can entirely choose which one you want to go for, whichever you find more convenient. So method 1 is using column vectors from the center of enlargement. So for this, if I just label these 3 points on triangle T, I'm just going to label them 1, 2, and 3. So to get from the COE to 1, what I need to do is I need to go to the left, to the right 2 squares and up 3 squares. Now if I then multiply that by the negative scale factor, so if I multiply that by -2, then what I end up with is -4 and -6. So then, and that's going to equal my 1 dash. So starting at the centre of enlargement, if I go to the left 4 squares, so 3, 4, and then down 6 squares, so 2, 4, 6, this is where my new number 1 is going to be. Now if I then do the same to point 2, so to get from the centre of enlargement to 2, I need to go 2 to the right and 1 up. So if I then multiply that by -2, then I'm going to get -4 minus 2. So again, going minus 4 to the left and then 2 down, this then becomes my new 2 dash. And then if I then do the centre of enlargement to 3, so again I'm going 3 to the right and 1 up. If I then multiply that by the scale factor, which in this case is minus 2, then I'm going to get minus 6 minus 2. So this time I'm going to go 6 to the left, which then becomes there, and 2 down, which then becomes there, and that then becomes my new 3 dash. And then all I then need to do is, with a ruler, which I'm not going to use, is then join those points up, and as you can see, this has now been flipped both horizontally and vertically, so the orientation is absolutely spot on, and the sides have also increased by a scale factor of 2. Now, to double make sure that you are doing this, and examiners are going to be wanting you to see this, is they're going to want to see projection lines of where they all match up. So for example, if I connect 1 with 1 dash, and let me just make sure that that is actually on the point. And then if I then get another line, it's in blue, oh, they changed it for me. So then if I then get point at 2, and then have this line going through 2, and then if I then do the same with 3, you can see that all the points, obviously just a bit skew with, you can see that all those projection lines do go through 2, 2, but I would always recommend that you then draw your projection lines. So let me just write it here and then draw projection lines to check. So that's one method you could do to perform an enlargement with a negative scale factor. So looking at method 2, so method 2 is using and measuring projection lines. So another alternate way of looking at this is if I draw my projection lines, and maybe a little bit more. So we're drawing the projection lines from that go through each of the vertices of the shape. Thankfully, triangles only got 3. And let's just click away so I can use a different color. Blue. Another one. Yeah. So, and let's then do third one. Goes through third vertex. And again, hopefully yours will be a lot easier and quicker. I know this is not the most entertaining things to be watching. I think that's about the best we're going to get. So if I then measure the distance from the centre of enlargement, which is here, to each of the vertices, so if I imagine that's 3.6, this is going to be, I don't know, 2.2, and let's say for argument's sake that this maroon claret colour is 3.4. So what I'm going to do is then with 3.6 is I multiply that by minus 2, and that gives me minus 7.2. Now the minus means I'm going in the opposite direction to the centre of enlargement. So then what I'm then going to do is measure where 7.2 centimetres is. So this distance here is 7.2, and put a little mark. Then I do 2.2, so 2.2 times minus 2 is minus 4.4. So going in the opposite direction of my centre enlargement, I measure 4.4, and that's again from the COE to the point in question. And then I repeat the same for the third remaining side. Which colour am I using? I'm using maroon. So then here I'm doing 3.4 times minus 2, which is going to give me minus 6.8. So I'm going to measure 6.8 from the centre enlargement, which is roughly around about there. So if I just mark where 6.8 centimetres is from there to there, well, I don't know why I've put units in there, let's get rid of that. And then I've got my 3 points, and then with my 3 points, all I then need to do is join those points up, and hopefully it should represent a enlargement with the scale factor stated from the centre of enlargement, which is just there. So there's two methods you can choose, whichever floats your boat. But like I said, I would say the column vector will be a lot neater, but it takes a little bit more time. But you need to make sure you are drawing your projection lines, because the correct way of enlarging shape is by doing method 2. However, there is a little sneaky way in which you can do it by looking at the vectors. Now, once you've got a couple of coordinates, you can guess where the other points are going to be, but in the mark scheme there will be expecting at least 2 projection lines being drawn, whether you've used method 1 or method 2. So moving on to describing an enlargement with a negative scale factor. Now, as I said, with this, you kind of need to use your common sense to first of all decide what the transformation actually is. Now, again, we're talking about a single transformation. So yes, we could, let's say, use reflection twice to get the orientation, but that's not going to alter the size. So for this, you always need to state the enlargement. So we know it's an enlargement because the dimensions have changed. The next thing we then need to do is the scale factor. Now, looking at how much bigger triangle T is to U, so we're going in this direction, is you can see that it's about 2.5 times bigger. So here the scale factor is 5/2 or 2.5. Now we also know it's been flipped, so it's going to be a minus. So I can write that there. Now the next thing for me to do is to find the center of enlargement. Now how do I do that? Well, quite easily actually. So what I do is I get a straight edge and I join the vertices, the corresponding vertices up together. And let's just use a different color. Let's go ahead so you can see it. And then let's do another projection line. And what you should find is that all the projection lines that go to the corresponding points should meet at the same point. So if I do all 3 ordinates, vertices rather, and again it's got to go make sure that you're going for the corresponding ones, you can see that all of them meet at this point here, this point here, so that is my center of enlargement. So then what I then need to make sure that I do is I write that as a coordinate, which in this case is -2, -2. Now often these questions are worth 3 marks, so you get 1 mark for stating enlargement, 1 mark for the correct scale factor, and 1 mark for the correct center of enlargement. Now if there are any bonus points, if it's, for example, if it's worth 4 marks, it might be because of the complexity of the shape, or they may be generous and give you marks for the negative on the scale factor, but also 1 mark for each correct ordinate of the center of enlargement. So let's have a look at some exam style questions. Now in this question it says that we need to enlarge the triangle by a scale factor of -1/2 using the center of enlargement of 2, 0. Now first things first, what we want to do is mark where the center of enlargement is. Now 2, 0 is here. Now obviously center of enlargement can be inside shapes, you just need to be mindful of this. Now we are going to be drawing a shape that is half the size of this triangle. So that's what we need to remember, that we're going to be drawing. So you can see the dimensions of this original triangle is 6/8. So we're going to be drawing a triangle that looks like, and it's going to be 3 along here and 4 along here. Now because we are going to be using a negative scale factor, then what this shape is going to look like, well, if I flip it vertically, it's then going to be 3, 4. And then if I flip it again, it's going to look like this. So this is basically what my new image is going to look like. So it's actually going to look like this. So it's always important that you have an idea in your head about what your shape is going to look like. Now for this, again, if I just show you the vector method, so labeling this ABC, here is my center of enlargement. So the COE 2 point A is going to be equal to 2, 4. So it's 2, 4. So then if I then multiply that by -1/2, then that's going to become -1, and that's going to be -2. So from that then, all we then need to do is actually go on to plot where A dash is going to be. So we're going to go 1 to the left and then 1, 2 down. So that's going to be here. So this is where A dash is going to be. Then looking at COE to B, that's going to be using a column vector of 2, -2. So then if I then multiply that by -1/2, then again 2 times -1/2 is -1, and -2 times -1/2 is going to give me +1. So that is the column vector I need for B dash. Let me just label this. So B dash is going to be 1 to the left and then 1 up. So that's where B is going to be. And then finally for C, so the COE to C, well, that is going to be 2 down. So that's minus, it's going to be 6 to the left. So that's minus 6. And then it's going to be 2 down. So that's minus 2. So if I then multiply that by minus a half, then what does that become? Minus 6 times a half is positive 3, and 2 times minus a half is positive 1. So then if I then from this point go 3 to the right and then 1 up, this then gives me C dash. And again, if I join those points up, again with a ruler, so we just get rid of that line because that was not drawn accurately at all, like so. And then just simply join those points up like there. And if I wanted to, I could shade it just to show where it is. Now if I then drew my extension lines, then they obviously would go through each of those points, so then that would be absolutely fine. So this is A dash, that's B dash, that's C dash, and as you can see that my triangle did eventually look like that. So looking at our second type of most common enlargement questions, so in this question it's asked us to describe fully the single transformation that maps triangle A to B. Now the wording is really important because we're going from A to B. Now as you can see, using my common sense, I know straight away that as the shape has changed its size, that we are looking at an enlargement. So just by writing enlargement would get me 1 out of the 3 marks. So the next thing I then need to do is work out the scale factor. Now for the scale factor, what I need to do is I need to do the side on the new shape divided by the corresponding side on the old shape. So here, if I take the base of those two triangles, I've got 2 over 6. So then the scale factor is a third. So I can write SF equals 1/3. Now this isn't going to be a negative scale factor because as you can see, triangle A has not been reflected vertically and it's not been reflected horizontally as well. So it's the end shape does not look like this. So it's not going to be a minus. The next thing I then need to do is find the center of enlargement. And let's just work that out. So to find that, all I need to do is draw lines through the corresponding points. So starting on the old shape, we just draw projection lines to and through the points on the new shape. Again, yours, if you do this on paper, should be a lot quicker than what I'm doing on the computer. And let's just do one there. As you can see there, so I'm looking at probably 5, 1, but let's just confirm by going for the third point. And you find that triangles are often used because you don't have to use that many points. So even if you were to go through the column vector method or using lines and measurements, then you should still be okay. So from this then we know that the center of enlargement then is going to be at 5, 1. And so we get 1 mark for enlargement, 1 mark for the scale factor being a third, and then 1 mark for the center of enlargement being 5, 1.